So far when we have been looking at common factoring, we're trying to see what's in common between all of the terms and take that out, divide it out. If it doesn't belong in all the terms, if I can't factor it out of all the terms, I can't factor it out. It's not a GCF. But in this example, we're actually going to explore a different type of common factoring called common factoring by grouping. Okay? Sometimes we don't have to factor out a common factor between all the terms in the polynomial. We can group the terms and then factor it out of the smaller terms. Let's take a look at this example. We want to factor this polynomial. Now, if you look at the number parts, 3, 3, -4, -4, the only thing in common is a 1. If you look at the x part, we have x squared, x, and then no x's here. If you look at the y's, well, we don't have any y's here, don't have any y's here, we have a y, we have a y. So essentially, the GCF between all 4 terms is 1. There's nothing else I can take out. But that's kind of boring. Dividing by 1 doesn't change the question. So does that mean this is not factorable? Not quite. Notice that if we look at the terms in pairs, they actually have a lot more in common. So I'm going to group these two together and call that group 1. And then I'm going to group these two together and call that group 2. Let's first look at group 1. What is the GCF? Well, in terms of the number part, 3 and 3. So 3 is a common factor. How about in terms of the variable part? Well, we have x squared and we have an x. So I can take out at least an x from both of them. Can I take out any more? Well, no, because the second term only has an x to give, so that's it. I can take out a 3x. Okay, so that was step 1. Step 2, I'm going to divide the terms in group 1 by this greatest common factor. So we have 3x squared plus 3x. I'm going to divide both of these by 3x. All right, 3 divided by 3 is 1. X squared divided by x, I just have an x left over. And the second term, 3 divided by 3 is 1. X divided by x is also 1. Be very careful. A lot of students I've seen in the past forget to write this plus 1. They think, oh, 3x cancels with 3x, there's nothing left. There's a 1 left over because 3x divided by 3x is 1, not 0. Okay, so that means that group 1, 3x squared plus 3x, could be rewritten as the GCF times whatever is left over after you divide by the GCF. So that's 3x times x plus 1. Cool, that's group 1. Now I'm going to pause the video. I want you to follow these 3 steps, the same 3 steps, to factor out group 2. So hopefully by factoring the second group, you got -4y times x plus 1. If you didn't get these, pause the video, double check your math there. Okay, so essentially what we have now is 3x squared plus 3x minus 4xy minus 4y, the original expression. We just factor that in pairs. The first pair gave us 3x times x plus 1. Second pair gave us -4y times x plus 1. So you might be thinking, okay, we just factored in pair, but is this done? Like, is this the fully factored form? Well, now, notice that we have 2 terms. Do these 2 terms have anything in common? Well, in terms of the numbers, we have 3 and -4. Common factor is a 1. We have an x and a y. Those are different. Oh, but now we also have an x plus 1 and an x plus 1. So the GCF is an x plus 1. So without writing out the steps, I know that this is going to be a GCF, which is x plus 1, times whatever is left over. So if I divide all these terms by x plus 1, the first term, the x plus 1 is gone, so we just have a 3x. Second term, x plus 1, again, it's gone. It divides out into a 1, so I'm left with -4y. Now, this is the fully factored form. We have 2 factors being multiplied together that will end up back at the original. And I will leave it as an exercise for you to check. Go ahead, expand and simplify this. You should end up back at the original expression. All right, part B, we want to do something similar here. We notice that we have m's, n's, x, and y's, but if you look at it very carefully, there's no common factor aside from 1 that goes into all 4 terms. So guess what? We're going to have to group them. So let's call this group 1 and this group 2. Now, hopefully by this point you have had enough practice with writing out step 1 GCF, step 2 divided out, step 3 factored form. I'm going to try to combine those a little bit. So for my group 1, what is the GCF? Between m and n, there's nothing there, but they both have an x. So I'm going to factor out, meaning take out an x. What's left over? Well, for my mx, if I take out an x, meaning I divide it out, I'm left with an m. For my negative nx, if I divide out an x, I'm left with a negative n. So that's the first part. The second part, second group, what do they have in common? M, n, y, numbers. Well, they have a y in common, a positive y. And if I take out a positive y, what do we have left over? Well, the first one here, dividing that out, I'm just left with an m. Second one, dividing that y out, I'm left with a negative n. So that's it. So this is my factored form when I factored in pairs. But of course, once we're done that, now we have two separate terms and we need to see if there's something in common between these two terms. X and y, nothing in common, but they both have an m minus n bracket. So now we can take out an m minus n. What's left over? Well, this first one, that divides out into a 1, so we just have x times 1, or just x. The second one, same thing, m minus n divided by m minus n is 1, so we're just left with a plus y. This is the fully factored form of this polynomial.